Okay, so we are taking a look at example 2 from the Boolean functions section of the book. And the main question that we're looking at is how many Boolean functions are there with a domain of x to the 3 set 0, 1, the Boolean set. So a couple of things as we're going to get into this, but a couple of terms we need to understand first. Right off the bat, we need to understand the term cardinality. Right? So cardinality, how many of something are there? How, a count. So if we define a set S, right, the number of items in that set is its cardinality, and we usually depict it by putting a bar on each side, right? So that's the count of the things. So if we go back to our Boolean set here, right? Remember, our Boolean set is 0 and 1. Then to depict the cardinality, we write a bar on each side. And how many items are in the set? Well, that one's easy. There are 2. Right? So there are 2 items in our Boolean set. Does that make sense? Okay, that's cardinality in a nutshell. Now, let's go back to a term or a definition, a symbology that we used last time, right? Remember, when we say something like x to the n 0, 1, what we mean is we have n items of this set 0, 1. So that means we have x1, x2, all the way down until we get to x3, right? Or 3, n. In our concrete example, we're using 3, but in the general case, we use n. So, 20, 30, 40, doesn't matter. We have an example of x for each of these. And what that really means is, for the first item, we have 0 or we have 1. For the second item, we have 0 or we have 1. All the way down until the nth item, right? So I'm going to put a little n there, 2, 1. Probably should use different colors, but that's the symbology. I'm going to insist that that's a term. That's the symbology that we've been using. So knowing that, what is the cardinality of this? How many? Well, we have 2 possibilities for the first one here, right? So this, it could be 0 or it could be 1. For each of those possibilities, we have 2 possibilities for the second one. So if we had 2 items, it'd be 2 times 2, and on down until we get to the last one, and there are 2 possibilities for that. So what does that mean? That means our cardinality is 2 to the n, right? Or really, more generally, we could say the cardinality of our set of 0 and 1 is 2, and that's raised to the n power, because for every item in our tuple, right, our n tuple, there are 2 possibilities. So we multiply them all together. I really want you guys to understand why where this comes from. From here to here is just basic math, but from here to here, this is the crux of it. And this is counting. Counting comes up a lot in discrete math. All right? Let's use a more concrete example. Let's use our x to the 3 of 0 and 1. Right? Let's do this concretely. So that means that I have 2 possibilities for the first value, I have two possibilities for the second value, and I have two possibilities for the third value. So we have two possibilities for the first one. We all understand that, right? It could be 0 or it could be 1. But we also have two possibilities for the second one. It could be 0, right, and 1. Or it could be 0 and 1 down here with the 1. So we have four unique possibilities so far, right? 0, 0, 0, 1, 1, 0, 1, 1. So we have 4 unique possibilities with our 2 tuple, which is what we came up with over here, right? 2 times 2. When we add the 3 tuple, right? Not a triple, a 3 tuple. Now we have 2 more possibilities for each of these. That's the key thing. So for, and this is not going to, I'm going to run out of room. I could have 0, 0, 0, right? I could have I could have 0, 1, 0. Or I could have, I'm going to stop doing different colors. I'm confusing myself. I could have 0, 0, 1, right? Or I could have 0, 1, 1. I could have 1, 0, 0 or 1, 1, 0. Or I could have 1, 0, 1 or 1, 1, 1. These are all 8 possibilities. 2 times 2, which is 4, times 2, which is 8, which is 2 raised to the third power. That is how we go from here to here. So, oh, you know what? I realize now that some of my writing was probably off of the camera. But I hope this makes sense. We're going to go over it again in class, but I want you to get the general idea. All right? So now, back to our original question. How many Boolean functions are there with a domain of x to the 3, 0, 1? So that's our domain. That's all possible inputs. Well, we know that the cardinality of that is 2 to the 3, which is 8. Right? We're just going to write 2 to the 3. And when we say a Boolean function with that domain, we mean, remember this syntax. So that means that, you know, a function that has the domain of 3 binary tuples, excuse me, a 3 tuple of binary values, and the range, the output, is a single binary value. So we know how many possibilities are here. There's 2 to the 3 or 8. How many possibilities are here? Well, there are 2 possibilities, right, for each one. But this is a little bit different than what we were talking about when we, you know, the intuitive answer to me is, oh, this is just multiplied by 2 again. For each of these possibilities, we can have 0 or 1, right, as the output. However, when we were exhausting all the possibilities before, once we had used it, it was used up. When we're talking about the range, for each potential input, we still have 2 potential outputs. And that we don't use one up, right? It's never gone. So in fact, how many Boolean functions are there with a domain x raised to the 3, 0, 1? The answer is 2 raised to 2 to the 3rd, right? Which is 2 to the 8th, which is, I don't know what that is. I don't care. But the key thing is, again, this is a counting problem. When we count the number of input possibilities, once we've used that 0 in that position with these other parts of the tuple, it's done. It's used. But we still have 2 potential outputs, and those 2 never go away. There's always 2 potential outputs. So this is a little bit confusing and not super intuitive, but these are the types of, it's going to start to come together. I just want you to know the terms and believe me and understand some of the basic math here, but trust me, we're going to continue on. It's going to start to come together as we continue through Boolean functions. If you have any questions, ask in the forum below.